In this lesson, we're going to prove deductively the Pythagorean theorem. Now, the Pythagorean theorem has been around a long, long time. The Babylonians first discovered the relationship between a hypotenuse and legs of a right triangle about 1,000 years before Pythagoras. And the Chinese also knew about it. In fact, this image at right shows one of the more popular triples. So you can see a side of length 3 here, a side of length 4, and a side of length 5. That's a 3-4-5 triple, or the 3-4-5 right triangle. Now, the Pythagorean theorem is named after Pythagoras and his followers for having the first known proof. And it involves something more. Now, Pythagoras didn't know algebra, so he didn't know this bit here, a squared plus b squared equals c squared. But he did know about squares. So he actually said, oh, a square from this leg and a square from that leg will be the same size as a square made from that leg. Now, we're going to use a more algebraic approach for our proof, and this is a diagram I'm going to use. So I've got 4 right triangles, each with a leg of length A and a leg of length B, and the hypotenuse is C. The square in the center has a side of C, and it all makes a larger square with length AB. So this side is A plus B. I'm sorry, I should have said A plus B. And this side is B plus A, which with the commutative property is the same as A plus B. Okay, so now we're going to use this diagram to make a proof. So I'm going to start with the area of each of these triangles. The formula is 1/2 base times height. Well, I can use A as the base here and B as the height, or B as the base and A as the height. Either way, it's going to be 1/2 A times B. So what's the total area? I've got 4 of these triangles, so I've got that big square. So it's going to be C squared plus 4 of these 1/2 ABs. 4 times a half. If you had 4 halves of a pizza, you have 2 pizzas. So it's C squared plus 2 times A times B. 4 times a half is 2. Now I'm going to look at the area of the larger square. And how am I going to calculate that? Well, for a square, area is side squared. In this case, it's going to be A plus B squared, which is the same as A plus B times A plus B. Now, I'm going to break this up a little bit so I can use a distributive property. This is the same as A of these plus B of these. So I have A times A, which is going to be A squared, A times B, which is AB, plus B times A, which I'm just going to write as AB, plus B times B, which is B squared. I can combine my like terms, and I get the total area for this large square is A squared plus 2AB plus B squared. If you probably remember FOIL or multiplying 2 by 2 terms. I personally prefer distributive property because it's more general and it works beyond that. So anyways, we're going to take both the areas we found, and they were the same total area, and we're going to set them equal. So this is from our first part, where we had the square and the 4 triangles. C squared plus 2AB equals. Then this is the area of the total square just using this side, A squared plus 2AB plus B squared. I can subtract 2AB from both sides, and that leaves me with C squared equals A squared plus B squared. You prove the Pythagorean theorem. C squared must equal A squared plus B squared. This is a deductive proof. So for further reflection, did the Babylonians and Chinese have inductive or deductive proofs for the Pythagorean theorem? And how can we deductively prove the Pythagorean theorem?